Alright, so here starts the examples portion of the notes. I'm going to try to move faster because I know the last video was way too long. So here we have an LRAM on one interval 1 to 6 with 3 subintervals. So 1 to 6 with 3 subintervals. Here we have an issue where, alright, let's go ahead and find out how wide our 3 rectangles are. And we do that by finding delta x, or the base. Alright, delta x is equal to 6 minus 1 a minus b minus a over n. 6 minus 1 over 3, that's 5/3. Alright, so each interval here is 5/3. Each interval here is 5/3. So from 1 to 6, 5/3. Alright, from 1 plus 5/3 is roughly 1, 2 and 2/3. So the first rectangle starts right there. And then 2 and 2/3 plus 5/3 is 3, 4 and 1/3, which is about right there. And then 4 and 1/3 plus 5/3 ends up being 6. So you have this here, here, and here. These 4 points. 2 comma. Actually, that's not 2. That's 2 and 2/3, or I'll say 2.6. Repeating, comma 2. And then 4.3 repeating, comma 2, and then 6, comma 2. Alright, so there we have it. Those are our 4 points that we're using. Let me go ahead and zoom in on this one. Okay. So, and this is our base. So let's go ahead and do it the easy way. I equals 1. How many things? 3. We're adding up 3 rectangles. Alright, so base times height. So the easy way would be 5/3 times 2 plus 5/3 times 2, because the base is always 5/3 and the height's always 2. So there we have it. I would do it this way. I would factor out a 5/3. 2 plus 2 plus 2 is 6. Okay, factor out of 5/3. 2 plus 2 plus 2 is 6. 6 times 5 is 30. 30 divided by 3 is 10. 10 units squared. Okay. Alright, now when you're doing this the hard way, it's really insignificant to do it the hard way, because if you do it, if you look at it, I equals 1, 3, right? Alright, delta x. Let's say we're doing an LRAM, right? An LRAM. Okay, so really this point right here does not even matter, because we're only focused on the left end points. Alright? So, and then we have f of x of IL. Well, here, this is always 2 no matter what. And this is always 5/3 no matter what. So there's no point in working it all out. It's 5/3 times 2 plus 5/3 times 2 plus 5/3. Sorry, 5/3 times 2. I wrote 5/2 right there. So I'm going to factor out of 5/3 again. 2 plus 2 plus 2. Because it makes no point for me to do it the hard way. 5/3 times 6 is, once again, 10 units squared. Alright, there we go. Now, once again, spiraling back, this is neither an upper sum nor a lower sum. It's neither, because it's exactly the same as if I were to calculate the whole rectangle. If you look at the area of the whole area under the curve, it's equivalent to the approximated area with the broken up rectangles. Alright, let's look at example 2. Alright, this one's a little bit more in depth. I'm going to zoom in so I can write small. Okay. Alright, here we go. Alright, doing an RAM on 0, 4 with 8 subintervals. So, well, let's go ahead and find our delta x. Delta x is equal to 4 minus 0 over 8, which is 1/2. So each rectangle is a half unit wide, and it's an RAM, so I just got to make sure that every rectangle intersects at the right endpoint. Alright. So there are all these points right here. Alright, and I'm just going to write out how tall each point is, because we know what the x values are. Alright, so this is 8, then 7, then 6, 5, 4, 3, 2, 1, 0. There's actually a height of 0. Alright, and this is what we call a lower sum. Now, let's talk about this easy way. I'm not going to waste time doing it the easy way anymore, because it's just one more thing I have to do. The easy way would simply be the summation of 8 things. Alright, I'll go ahead and write it down, but we won't work it out. I equals 1 to 8, base times height. Then I would just list each base. I would list 0.5 and the height 7, 0.5 and the height 6, 0.5 and the height 5, 0.5 and the height 4, 0.5 and the height 3, 0.5 and the height 2, and so on and so forth. Okay, so there we go. But now I'm going to convert it into the proper formula. Delta x, f of x of I, r. So let's find x of I, r. Alright, this was the first step. That's the most important thing. Second step, x of I, r. Alright, we should know that from our notes. A plus delta xi. So x of I, r is 0 equals 0 plus 0.5i. So x of I, r equals 0.5i. Alright. Now we gotta find f of x of I, r. Now I'm not gonna retell you what f of x is. You know what f of x is. It's right there, 2x minus 8. So let's just do f of x of I, r. Because we know what f of x is. 0.5i has to go in for every x, so that's 2 parentheses 0.5i minus 8. F of x of I, r equals 2 times 0.5, which is 1i minus 8, so simply I minus 8. Now, that's the third step. Now I'm ready to finally put it in the summation formula. Okay, let me go ahead and section these two problems off. Alright, so summation formula, step 4. Okay, it's the summation of 8 things, of 1 to 8 things, and delta x is 0.5. F of x of I, r is I minus 8. And I'm going to take the liberty of factoring out the 0.5 to make the work easier. Alright, so that is going to equal 0.5 times, well, it's just going to be 1 minus 8. Plug in 1 minus 8, plus 2 minus 8, and then, plus 3 minus 8, plus 4 minus 8, and I'm just going to continue this way, plus what's 5 minus 8? 3, plus what's 6 minus 8? 2, plus what's 1? You know, so 5 minus 8 is 3, 6 minus 8 is 2, 7 minus 8 is 1, and 8 minus 8 is 0. Okay, so this is really 0.5 times, sorry, actually that's negative 3, negative 2, and negative 1, my bad, sorry, negative 3, negative 2, negative 1, so 0.5 times negative 7 plus negative 6 plus negative 5 plus negative 4 plus negative 3 plus negative 2 plus negative 1 plus 0, which all that, 7, 6, and 5, see 6 and 5 is 11, and 7 is 18, and 4 is 22, and 3 is 25, 27, 28, so 0.5 times 28 equals negative 28, excuse me, equals negative 14 units squared. Now in this case, y'all, you can have a negative answer. You definitely can have a negative answer. You could actually have a 0 answer. Alright, so I hope this was understandable for your f of x of IR. Okay, let's go ahead and move on. Alright, example 3. Zoom out. Get some scrolling here. Alright, so this one's going to be fairly difficult. I'm going to try to work through it as neatly as possible. But six subintervals using MRAM, okay, of this on 3, 5. Alright, so we got 6 subintervals. Well, first let's find our delta x, okay, and I think I can get away with zooming out just a little bit more, yeah, so I have more room to work. Alright, delta x is equal to b minus a over n, which equals 5 minus 3 over 6, which is 2/6 or 1/3, okay? Like I said, I'm not doing it the easy way, but we'll talk about the easy way. Alright, so delta x, each rectangle is a 1/3 unit long, or wide, excuse me. So that's breaking it up into 6 rectangles from 3 to 5. And each of these rectangles intersects at the midpoint. And it's hard to draw these, but just imagine that they're intersecting at the midpoint, please. Alright. Alright, so there we go. So all those are intersecting at the midpoint. Okay. Now, normally we'd have to figure out what those x values are if we're doing it the easy way. And it's kind of easy. You go 3, start at 3, and what's half of a third, which is 6. So this would be 3 and a 6, and I would plug that in to find the point. But we don't have to if we have a formula. So that's step 1. Alright, let's just go through the steps. Step 2. Alright, find x of IM. Okay, so f of x of IM, or x of IM is equal to a plus delta x. Alright, I minus 1/2. Okay, and so x of IM equals 3 plus 1/3 I minus 1/2 x of IM equals, well, that's ends up being 3 plus 1/3 I minus a 6. So 3 is common denominator. 3 would be it would be 18 over 6. x of im. Alright, so that'd be 17 over 6 plus 1/3 I. Okay? Alright, now let me go ahead and tell you, this problem is about to get really rough, but let's push through it, okay? So this is step 2. Let's go ahead and move on to step 3. We're going to need some room. Alright, step 3. Alright, f of x of im. Alright, so we know f of x, it's 1/2 x squared minus 2, so now we have 1/2 17 over 6 plus 1/3 I squared minus 2. Okay, now I'm going to go ahead and take a little shortcut, and I'm going to not FOIL. Okay, I know this is kind of crazy because I did it on the previous example on the notes, but I think it's going to take us way too long to FOIL this out. Okay, it's going to take us way too long. There's no point really. We found f of x of im. That's all there is to it. Okay, so that's all we need. So we're going to skip down to step 4. I know some of y'all are really breathing a sigh of relief right now. So the summation from I equals 1 to how many? 6. We're adding 6 things. Delta x and f of x of im. Delta x times f of x of im. That equals, or yields, the summation from I equals 1 to 6. Delta x is 1/3, f of x of im is all that, 1/2 17 over 6 plus 1/3 I squared minus 2. Okay, now so let me break down how we're going to add these up. So, I mean, I guess you could bust out your calculator right now and go ahead and figure these, but I don't have a calculator, and this may or may not be a calculator question on the AP exam. So, let's go ahead and work through it. First of all, I'm going to take the liberty of factoring out this 1/3. Actually, I'm going to actually do it on the next row. 1/3. And so I'll have 1/2 17 over 6 plus 1. Now I'm plugging in 1. So 17 over 6 plus 1/3 minus 2. Alright? So yeah, there we go. That's 1. I factored this out. So I plugged in 1. Now I gotta put a plus sign and plug in 2. So 1/2 17 over 6 plus 2/3. Yep, minus 2 plus, and I could have parentheses around these. Yeah, that would be better, but it doesn't matter. Now, you guessed it, we got to do this again. Okay, so dot dot dot. Okay, so let's go ahead and like I said, you could just plug all this in your calculator and figure it out. Alright, but I'm going to work through it all. Alright, so let's continue. I'm actually going to continue this here. Okay. Alright. Alright, so there we have it. Alright, now I'm going to add all this up, but before I do, I want us to realize a couple things. Look at all these minus 2's. Like I said, you can use your calculator, that's just fine. You can get common denominators, that's just fine. But there are 6 negative 2's, so I can convert this into 1/3 6 times negative 2. Alright, now plus 1/2, and now I'm going to start with the common denominator. 17 over 6 plus 1/3, well that's 2/6, and then plus 1/2, 17 over 6 plus, well, 2/3, that's 4/6. And now we have a pattern, so it's kind of easy to continue. One, two, three, four, five, 6. Alright, now I'm going to actually, I know y'all are like, what? But I'm going to take this a step further. Alright, so I'm going to actually factor out that 1/2 now. Like I said, if you just want to plug in your calculator, fine. That's okay, but you're going to have to, well, you don't have to, but this is part of it. Learning to algebraically manipulate these fractions. 1/3, 6 times negative 2. I'm factoring out the half. I'm factoring out the half. So 1/2 plus 1/2. Now notice if I factor out this 1/2, notice what I have left over. I've got 6 17 over 6. I've got 6 17 over 6. So that's 6 times 17 over 6. Okay. Then I've got 2 over 6 plus 4 over 6 plus 6 over 6 plus 8 over 6 plus 10 over 6 plus 12 over 6. So I got 6 17 over 6. Then I got 2 plus 4 plus 6 plus 8 plus 10 plus 12 all over 6. Now this becomes very, very easy. 1/3. Like I said, you can always just plug this in your calculator, guys. I'm not trying to force you to do all this. Uh-oh. My pencil is running out. Negative 12. And that cancels. Plus 1/2. 17. 2 plus 4 is 6, and 6 is 12, and 8 is 20, and 30, and 42 over 6. Plus 42 over 6. 1/3, negative 12, plus 42 over 6 is 7, and 17 is 24, so 1/2, 24, 1/3. Oh, what half of 24 is 12, so 12 plus negative 12 equals 1/3 of 0. Well, what do you know? Our answer is 0. 0 units squared. Alright. Now, I know that was a doozy, but here's the thing. At this point right here, we could have been done. You could have plugged it in your calculator, but you need to understand and be aware of the algebraic manipulations that can occur. They don't have to occur. Alright? So let's move it on. Let's move on, okay, guys? Alrighty, that was example 3. Example 4. Alright, f of x is equal to 1/2 times 2 to the x power. Alright, so we're going to use TRAM on 1 to 4 with 3 subintervals. So that means there's going to be 3 trapezoids. Trapezoids have a straight top there. I know I could do a better job of this, but this is the best I can do. Alright. So there are my trapezoids right there. Okay. Those are my trapezoids. This is a little too bright. Maybe it's because the sun's coming up. Alright, so so we could do this the easy way. We would just have to figure out these points, and that would be pretty easy. I plug in 1, I'm going to get 1 actually, and I plug in 2, I'm going to get 2 actually, 2 comma 2, and I plug in 3, I'm going to get 4.5, so 3 comma 4.5, and then I plug in 4, I'm going to get 4 comma 8, okay, and I could figure it out pretty easy, 1/2 base times height, but you know, I'm not going to do that, because that's too easy and you don't need to waste time. Okay, so we got 3, we're adding up 3 things, and the things we're adding up are trapezoids, so 1/2 base 1 plus base 2 times the height. I always want you to start out like this because it's easy, and from here I remember that 1/2 is just 1/2. Base 1 is actually the f of x of IL. Base 2 is actually the f of x of IR. And the height is delta x. That's from your notes. Alright, so there you go. Alright, the brightness is still aggravating me. Alright, well we already know delta x. We don't even need to use the formula really, because we already know that's 1. Okay? So I'm starting my next step, but I'm not going to go there. I'm going to go ahead and work out delta x. I know delta x is equal to 1. Okay, that's step 1. Step 2, I need to find x of IL and x of IR. So x of IL is a plus delta x I minus 1. And x of IL is equal to, so a is 1, so 1 plus delta x is 1, I minus 1, distribute the 1, oh geez. So x of IL is equal to 1 plus I minus 1, which x of IL is equal to plain old I, because those cancel, okay? There is fx of IL. Let's go ahead and find f of x of IL now. Let me go and scroll down. Alright. F of x of IL. Well, f of x, I don't need to remind you of that. It's right here, 1/2 2 to the x power. Okay, so now we're plugging in I in for every x. So that's just 1/2 2 to the I power, which is fine. Now we're not done with these 2 steps because we got to go back and find x of IR. X of IR is a plus delta xi. And so x of IR, a is 1, 1 plus delta x is 1 times I, so x of IR is 1 plus I. Now I gotta plug that in to f of x to make f of x of IR. So this is gonna give me 1/2 2, and everywhere I see an x in the function, right here, I'm gonna put a 1 plus I. 1 plus I. There we go. Alright, now I'm ready. I've got my f of x of IR, I've got my f of x of IL, I know what my delta x is, I'm ready to go. Okay? So this is 1/2 f of x of IL, which is 1/2 2 to the I power, plus f of x to ir, which is 1/2 to the I minus 1 power times delta x, which is 1. I'm going to go ahead and get rid of that. And I'm going to go ahead and write that here again. Now watch this. This is where algebraic savviness helps. They got 1/2 in common, so I'm gonna factor out a 1/2. Factoring out a 1/2 with this 1/2 out here yields 1/4. 1/4 bracket. And I'm gonna go ahead and rewrite the whole thing so I don't confuse myself. 1/4 2 to the I power plus 2 to the I minus 1 power. See, that's much easier. Now I've got a 1/4, okay, a 1/4, and I'm plugging in 1, and then I'm plugging in 2, and then I'm plugging in 3, and then that's it. I'm done. So plug in 1, what's 2 to the first power? 2, and then plug in 1 into both. We plug in 1 into both. 1 minus 1 was 0, so 2 to the first plus 2 to the 0, and that's in parentheses if you want it, plus 2 to the plug in 2 squared plus 2 to the first plus 2 to the third plus 2 to the second. We already have a pattern going, but you know, we didn't even need to go that far. So it's 1/4 2 plus 1 plus 4 plus 2 plus 8 plus 4. Okay, so that's 1/4 3 plus 6 plus 12. Alright, so 1/4, 3 and 6 is 9, and 12 is 21, a fourth of 12. We just call that, we'll call that 21 over 4 units squared. Okay, now let me go ahead and pan out. If you can do a problem like this, if you can follow this, then you have nothing to worry about, ladies and gentlemen. Okay, this is probably one of the type of problems I'm going to put on your test. Okay, in your review that you'll get tomorrow. All right. So let's move on. Let's not waste any time. We've got to go to example 5. Where is it? Which is I lost track of all these papers. Page 7. Where's page 7? Oh, there's page 7. Okay. Alright, so we have a sinusoidal now, okay? And it's not difficult. It's the same stuff. Step 1, let's read our problem and find delta x. So pi to 3 pi. So that's pi to 3 pi. We got 4 subintervals using LRAM. Well, it's easy to see that it's broken up nicely into 4 chunks. And here I'm using LRAM. It's fairly easy to calculate or figure out where my rectangles are. So basically, sometimes you can find your delta x by just saying, alright, I got 4 subintervals, 4 rectangles. This breaks up nicely into chunks like this. This is my delta x. How wide the rectangles are, that's your delta x. Okay, so right here delta x is from pi to 3 pi over 2. Well, that's adding pi over 2 every time. So pi over 2 is your delta x. Now you could plug each one of these points into the formula and figure out what your values were, but that would be the easy way, okay? We're going to do it the hard way with LRAM. So step 1, find delta x, and it's b minus a over n. So 3 pi, well actually we already found delta x, we talked about that, we don't have to work it out. It's pi over 2. Alright, step 2, let's find our x of IL. Uh-oh. Alright, x of IL is equal to a times plus delta x times I minus 1. X of IL is equal to a, which is pi, plus delta x, which is pi over 2, and I minus 1. So x of IL is equal to pi plus pi over 2i minus pi over 2. Okay. So what's pi minus pi over 2? Well, that's pi over 2. X of IL equals pi minus pi over 2, which is pi over 2, plus pi over 2i. Alright, so what? That's step 1. Step 2, now let's move on to step 3. My pencil's about to bite the dust. Oh Lord. I guess I'm going to have to use pen. Shame on me. Alright, so step 3. Gotta find f of x of IL. Alright, so that's sine pi over 2 plus pi over 2i over 2. I plugged pi over 2 plus pi over 2i. I had to plug it in to the original function. Alright. Well, if I'm good with fractions, I'll know that I'm just going to divide both of these by 2. What's pi over 2 divided by 2? It's like times 1/2, so it's 1/4. So f of x of IL equals sine of the pi over 4 plus pi over 4i. There you go. I know it's crazy. So now we're going to sum. We're going to do the summation of 4 things, 1 to 4, of LRAM, which is just delta x times f of x of IL, and delta x is pi over 2, so pi over 2 times f of x of IL, which is sine pi over 4 plus pi over 4i. Alright, so when I start plugging this in, I'm going to cheat. I'm going to cheat like crazy. Pi over 2, I'm factoring it out. So multiplying constant, I don't care. And I'm just going to plug in 1, 2, 3, and 4. Alright, but when I plug in 1, watch. Pi over 4 plus pi over 4 times 1. Okay? I know that that's going to be pi over 4 plus pi over 4, which is 2 pi over 4, which is pi over 2. So sine of pi over 2. And I know what that is. That's 1. Plus, now I plug in 2. So that's 2 pi over 4 plus pi over 4 is 3 pi over 4. Okay? The sine of 3 pi over 4, I know that's the square root of 2 over 2. So see, I'm cheating. I'm not showing all these steps. And then the next one is going to end up being, so you see the pattern here with these, hopefully, well, I'm basically adding pi over 4 every time. So the next one's going to be sine pi pi over 4 plus pi over 4 times 3. So that's 3 pi over 4 plus pi over 4 is 4 pi over 4, which is sine of pi, which is 0. I like that one. And the next one will be sine of 5 pi over 4, which is negative square root of 2 over 2. Well, this is lovely because these two cancel out, and I'm left with 1 times pi over 2. So my answer is pi over 2 units squared. Bada bing, bada boom. Okay? Not too shabby. If you just work with your fractions, it's not too difficult. All right? So let's keep moving on here. All right? Taking up way too much time, I know. All right, example 6. This one's fairly easy. We're going to use an RAM, right? F of x equals 1 over x. All right, and we're not going to do it the easy way. Of course, I could find these points easy. That would be plug in 1, and 1 over 1 is 1. And then 2. Actually, well, that's not even... Should be 1 to 4. Sorry about that. 1 to 4. Sorry about that. Alright. So 2 comma plug in 2, you'll get a half. And then 3 comma plug in 3, you'll get a third. And then 4 comma plug in 4, you get a fourth. Alright, so I can figure this out the easy way because it's RAM on the interval 1 to 4, and so my rectangles have right endpoints. Yeah, so that would be easy to do, but of course we can't do it the easy way. Don't you love it? We've got to use our summation. I equals 1 to 3. Alright. And we're doing base times height, so that's change of x, and f of x of I r. And so let's start with our steps. Step 1, find change of x. That's 4 minus 1 over 1. Sorry, my bad. 4 minus 1 over 3, which is 3 over 3, which is equal to 1. Step 2, find x of I r, which is a plus delta x I. X of IR equals 1 plus delta x is 1 times I, so x of IR is equal to 1 plus I. There we go. And then step 3, f of x of IR equals plug in I plus 1, or 1 plus I, sorry, doesn't matter. 1 plus I in for x. Ba-boom. So now we use our formula. Step 4, summation. I equals 1 to 3. We're adding 3 things. Delta x is 1, which I don't even need to put. F of x of IR is 1 over 1 plus I. Let me simplify this. Let me say I equals 1 to 3. I'm just going to write 1 over 1 plus I. And then I'm going to write it out. No trickeration. Plug in 1, I get 2. Plug in 2, I get 3. Plug in 3, I get 4. Man, couldn't every problem be like that? That would be awesome, wouldn't it? So 1/2 plus 1/3 plus 1/4, got to get common denominators, which I believe the closest one in this case is 12. So times 6 times 6, 6 over 12, plus times 4 times 4, 4 over 12, plus times 3 times 3, 3 over 12, and 6 and 4 is 10, and 3 is 13 over 12 units squared. Okay. All right, so we're pretty much done except for the biggest example there is. This is so huge into understanding everything, okay? Alright, this last example right here. Alright, number 8. Only graphical and numerical. Alright, we've got a function that is the velocity function in miles per hour. It's just a numerical, no equation for it, numerical function. We want to estimate the area under the curve using RRAM on 0 to 6 with 6 subintervals. That's easy. Let's draw a rectangle. This rectangle's right endpoint is at 0. Sorry about your luck. Right endpoint's at 2. Right endpoint's at 7. Right endpoint's at 16. Right endpoint's at 22. And right endpoint's at 29. Okay. Once again, this is a lower sum. Alright, so we're finding the area under the curve. So let's write it fancily. We use our fancy schmancy notation. I equals 1 to 6, base times height. Alright, all the bases are 1, so I don't even need to write them. I can simply just write the heights. 29 plus 22 plus 16 plus 7 plus 2 plus 0. Alright, so 29 and 22 make 31 and 51. And 16 make 57, 67, and 67 and 7 make 74, and 2 and 76. So equals 76 units squared. Alright, let's figure out what this answer means. Basically, and this is what you really have to pay attention to, okay, for AP exam purposes. So AP Importante. Okay, AP important. Alright, so what you've done is you said, okay, alright, so what you've done with this base times height, you've taken the time, a time times a velocity. Okay, the base times height is a time times a velocity. Let's see, this is a time, this is that stands for the velocity. So let's do an experiment. If you drive 29 miles per hour for 1 hour, what's the distance you've traveled? 29 miles. And if you do 22 miles per hour for 1 hour, you've driven 22 miles. And if you've done 16 miles per hour for 1 hour, you've done 16 miles. And it's time times velocity, which is kind of like rate times time. What does rate times time equal? Distance, y'all. Y'all known that forever. But that's huge. That's like thebomb.com. That's like the Big Mac Daddy thing you need to understand right now. When you do a Riemann sum and you find the area under the curve, if you're doing the velocity function, you're doing distance equals rate times time. The answer is in, not only is it 76 units squared, our answer means the distance traveled from t equals 0 to t equals 6. Now, of course, it's approximate. It's the approximate distance traveled. But it's the distance traveled. And what are its units? Let's see, okay, we found the area under the curve, and they were each base times height, so it was time times velocity. So it was miles per hour times hours. All right, that was the height, the v, and this was the base, the t, the delta t, really, delta t. So you did miles per hour times hours. What are its units? It's going to equal miles. All right. So its units are in miles. So this thing traveled. Excuse me. All right. This thing traveled approximately 76 miles in 6 hours. And this is not exactly the way you need to say it. Exactly the way you need to say it is this is the distance traveled from t equals 0 to t equals 6. Okay? But either one of these are correct. They're just not verbally exact. Alright, so that's it for this video. Okay? Now you have some examples to do. Alright? And these examples, I'm going to post the solutions for these. So what I want you to do is I want you to try to work these out. These practice examples, they're on the PowerPoint that's on the link on my website. So I think all these problems are not going to be too ugly. All right. I hope that they don't aggravate you too much, and I hope that they don't take too long. But that's what we got right now. And hit me up with any questions via email. And I'll talk to y'all later. Bye.